It started subtly, a missing slice of fruit, a disrupted garden path, nothing out of the ordinary. But soon, something shifted. Ant colonies from Brazil to Bangladesh began behaving differently. Scientists noticed anomalies first. Ants that once competed across species lines were now cooperating. They were no longer territorial. In fact, they began merging, combining nests, sharing workers, even pooling food resources. Normally, ant colonies are fiercely protective. A foreign ant is killed on sight. But now, species that had been rivals for millennia were allowing each other into their tunnels. No fighting, no hierarchy, just unity. It was as if an invisible signal had passed through the Earth's crust, rewriting instincts encoded by evolution itself. These weren't simple insects anymore. They were something more, a decentralized intelligence that had just discovered its strength in numbers. One scientist compared it to neurons waking up and realizing they're part of a brain. Across continents, reports surged of supercolonies, spanning hundreds of miles, connected through massive underground networks and pheromone highways. Ants were forming patterns previously thought impossible, bridges of living bodies across rivers, coordinated foraging routes lasting days, nest expansion projects that moved soil at the scale of minor earthquakes. And still, humanity didn't notice. Not really. We were too busy with our own lives, our own screens, our own wars. But beneath our feet, the Earth was changing. A silent network was growing. And for the first time in history, it was global. Communication has always been the key to civilization. For ants, it's no different, except they don't speak or write, they scent. Ants use pheromones, chemical signals to share everything, directions, danger, even death. But now, with the rise of the global megacolony, these signals don't just carry across a backyard, they carry across continents. What we're seeing is the emergence of a biological internet. Long trails of ants become data highways. Pheromone messages are encoded in subtle variations, like digital packets, only they're layered in scent. Scientists have observed command pheromones that mobilize entire regions of ants to redirect labor. One trail in Argentina, when analyzed, stretched over 300 kilometers, and every ant along the way followed it precisely. In California, a trail laid by one species was picked up and completed by another from across the ocean, possibly transported through shipping containers, but somehow understood. This isn't just coordination, this is integration. The pheromone web adapts in real time. If one trail is disrupted, scouts rebuild it instantly. Redundancy, optimization. And the most chilling part? These trails often pass directly through our homes, our streets, our tech hubs, invisible but deeply mapped. Some experts believe these pheromone signals are now encoded in multiple dimensions: surface trails, underground tunnels, even airborne molecules triggered by heat or vibration. It's not far-fetched to say the ants have created a new form of wireless communication. No power, no hardware, no downtime. A living network. Silent, hidden, and far more efficient than anything humans have built. We thought we ruled the web, but maybe we've been crawling on theirs all along. As the pheromone web expanded, something unexpected happened. The ants began moving inward, into our cities, not just into walls or pantries, but deep into our infrastructure. Ants have always been excellent invaders. They can crawl through cracks the width of a paper edge. But now, with a global network to guide them, they became surgical in their movements. They bypassed toxic bait and traps. They mapped heating ducts and power grids, and they began claiming territory, not randomly, but strategically. Major metropolises became silent battlegrounds. Inside apartment walls, ants laid pheromone markers near Wi-Fi routers and electrical panels, possibly sensing electromagnetic patterns. In office buildings, security cameras caught them marching in straight lines through data centers, ventilation shafts, and beneath server racks. A colony was found operating under a tech company's mainframe in Seoul, thriving off circuit heat and leftover crumbs. In New York, subway tunnels were compromised. Maintenance workers found vast nests hidden behind panels, so synchronized that trains would pass, and within seconds, the ants returned, undisturbed. Then came the sabotage. Power surges in São Paulo, server crashes in Singapore, disrupted fiber optics in Tokyo. Coincidence? Or testing phases of ant-coordinated strikes? The ants weren't just living among us. They were learning, understanding our weaknesses, and perhaps setting up for something far more sinister. Cities, once our greatest triumphs, were becoming incubators for the colony's next stage, and still, no one noticed. Just a few bugs here and there, they said. But beneath the asphalt and the LED lights, the invasion had already begun. As cities became infested, the countryside fared no better. The megacolony had no borders. No ecosystems were off limits. In forests, native insect populations began to vanish. Beetles, termites, wasps outcompeted or devoured. Birds that relied on these insects for food began starving. Frogs croaked in silence. Small mammals migrated or died. On farms, crop yields plummeted. Not because the ants ate the crops, but because they disrupted pollinators. Bees were attacked en masse, hives dismantled. Butterflies? Gone. Without these key species, plants struggled to reproduce. Pollination slowed. Fruit trees bore less. Wildflowers disappeared. In coastal regions, shorebird populations collapsed as crabs and larvae, normally their food source, were decimated. The ants didn't consume everything, but their presence disrupted the balance of every niche they entered. Entire ecosystems started unraveling like threads pulled from a tightly woven tapestry, one strand at a time. Invasive ant species had already done this before, on small scales, but this time it wasn't an isolated rainforest or remote island. This was planetary. From mangroves in Indonesia to prairies in the US, monoculture ant zones took over. Everything began to look the same. One species dominating, one food source, one colony rule. Scientists called it the silent collapse, because there were no roaring fires, no tsunamis, no nuclear flashes, just less birdsong, fewer butterflies, a forest that no longer buzzed. And in that silence, the ants marched on, replacing biodiversity with efficiency, replacing life with order. And if that's not terrifying, what is? Chapter 5, Script. For most of history, ants were considered simple creatures, driven by instinct, not thought. But now, scientists began to question everything. Observations revealed problem-solving behavior, ants altering paths based on real-time changes, bypassing obstacles with efficiency previously only seen in machines. One study recorded an ant colony rerouting its entire trail system after a chemical barrier was introduced. Within minutes, they not only found a new way, they began deploying scouts ahead of time to anticipate future changes. It wasn't just adaptation, it was strategy. Over generations, compressed by the sheer size and speed of the megacolony, evolution accelerated. Some species began to display hybrid characteristics, stronger mandibles from one, acid defense from another. Intelligence wasn't rising in individuals, but in the collective. The megacolony behaved more like a living organism, processing information across millions of nodes, reacting faster than any predator or machine. In one documented case, a group of ants constructed a temporary dam out of leaves and dirt to divert rainwater from flooding their nest. No blueprint, no leader, just instinctive coordination. And then came the ambush tactics. Ants lying in wait in power outlets for warmth, coordinated attacks on beehives, using decoy lines to draw defenders away while another force snuck inside. This was no longer coincidence. It was war planning. The line between instinct and intelligence had blurred. We weren't watching ants evolve. We were watching a new entity emerge, a networked, adaptive, intelligent system that had no central brain and no central weakness. And as it grew, it began learning from its most complex subject yet, us. Humanity did what it always does when faced with a growing threat. We fought back. Governments launched eradication campaigns. Pesticides were dumped by the ton. Underground nests were burned. Fields were flooded. But nothing worked. These weren't scattered invaders. This was a networked force, decentralized and adaptive. Kill one nest, and another 10 would reroute around it. And worse, the ants began avoiding poisoned zones before exposure. They'd watch, wait, then send in sacrificial scouts. If one died, the colony avoided the area. If 2 made it back, it was greenlit. Their learning curve was exponential. Each failed human attempt became part of their collective memory. Some nations tried tech-based solutions, sonic repellents, EMP pulses, even AI-controlled drones designed to track pheromone patterns. But while we needed satellites and algorithms, the ants just needed more ants. Millions of them. Billions. Self-replicating. Disposable. Relentless. Cities attempted to seal infrastructure, but the ants didn't need main roads. They built their own. Beneath floors, inside walls, through sewage lines. And for every system we built to block them. They found cracks we didn't even know existed. This wasn't a war against bugs. It was a war against decentralized intelligence. And the very traits that had once made us the dominant species, tools, technology, specialization, became our crutch. Because the ants didn't need leaders, didn't need downtime, didn't need fear, just coordination. Just numbers, just time. And time was something they had in abundance. Humanity had reached a breaking point. Cities fell, food chains collapsed, territory was lost. The war wasn't over, but our way of life was, so we adapted, or tried to. Urban centers began transforming into vertical cities, elevated and sealed off from the ground. Concrete towers with minimal ground-level access. Supplies delivered via drones, waste flushed into isolated underground tanks. Some regions even built hovering habitats, floating structures above forests and rivers out of reach. Scientists worked around the clock, not on eradication, but containment. Giant moats filled with repellent compounds, laser grids that fried swarms mid-air. Even pheromone cloaking tech, spraying false signals to confuse nearby colonies. But none of it was permanent. Every fix had a flaw. Every defense, a ticking clock. The global economy shifted. Agriculture moved to vertical hydroponics and sealed towers. Pest control became the largest global industry. Even education changed. Children taught how to identify scout patterns, how to seal microgaps, how to coexist. In some regions, coexisting became survival. Communities built symbiotic zones, offering food to small ant outposts in exchange for peace. It was crude diplomacy, but it worked, and while the megacolony didn't speak, it responded. Peaceful regions were left alone. Aggressive ones were swallowed. In time, humanity became more cautious, more defensive, more efficient. But we were no longer the apex species. Not truly. We lived above the surface, cut off from soil, from earth, from what used to be home. Below us, the world belonged to the colony. And whether we called it surrender, adaptation, or evolution, it was their world now. In the end, humanity didn't win, but we didn't go extinct either. We entered a new era, one defined not by dominance, but by balance. In ant-free zones, humanity began to rebuild, not in defiance, but in caution. We studied the swarm's behavior, learned to predict it, and eventually respected it. Diplomacy, of a strange kind, began to emerge. Zones marked with non-aggression pheromones were left untouched. Offerings of compost, sugar, and waste were exchanged for silence. And the ants? They didn't seek our extinction. They weren't malicious. They were just efficient. Their expansion slowed, not because they were defeated, but because they reached equilibrium. Resources balanced, predators adapted, humanity adapted. Scientists began speculating. Had the megacolony developed intuitive ecological sense? Did it understand sustainability better than we ever had? We once feared their swarm. Now we studied their structure. Cities were redesigned using decentralized infrastructure, redundant systems, adaptive layouts, swarm-inspired logistics. Our societies became leaner, faster, less wasteful, because the ants had taught us something no war or revolution ever could. That intelligence doesn't always look like us. In time, the story of the great megacolony wasn't told as a warning, but as a turning point, a moment where nature reminded us, even the smallest creatures can shape the fate of giants. And as we stood in our towers above a world now split in two, one ruled by silicon and steel, the other by soil and swarm, we finally understood. The earth was never really ours to begin with. We were just renting it.